Hey y'all, welcome back. On tonight's homework, we are using the power rule, which is going to be a huge shortcut for us so we do not have to use the limit definition of the derivative. So number 1A here says actually go ahead and use the limit definition of the derivative. This is going to be the only problem on tonight's homework where you have to do that. I want to make sure that you don't forget how to do this. Later on, there'll be problems where you have to recognize that you have to recognize the limit definition of the derivative. So I don't want you to just completely flush it out of your memory. So from time to time, I am going to have you work maybe once here or there where I require you to use the limit definition. Most of the time I will not, though. So let's go ahead and find this derivative using the limit definition. So f prime of x, that's the slope of f of x, or the derivative of f of x, is equal to the limit as h approaches 0 of f of x plus h, which is 4 times x plus h squared minus 2 times x plus h plus 1. So all that is f of x plus h minus f of x, which is 4x squared minus 2x plus 1 all over h. Now we'll go ahead and simplify that numerator a little bit. So I've got 4 times x squared plus 2xh plus h squared minus 2x minus 2h plus 1, and then minus 4x squared plus 2x minus 1 all over h. And I think what I'll do is go ahead and multiply that 4 in, not necessarily as a whole another step, but just I'll go ahead and erase and just distribute it like right here, basically. So 4 times x squared is going to be 4x squared. Then 4 times 2xh is going to be 8xh. And then multiplying by that h squared is going to give me 4h squared. Okay, so now what I'm going to do is look for opportunities to cancel some of these terms out by finding opposites that sum to 0, and then eventually, hopefully, we can find a factor of h that we can use to reduce and get rid of that h in the denominator. So I see we've got 4x squared minus 4x squared. Those are going to sum to 0. 2x minus 2x will sum to 0, and then the 1 minus 1. And we do have an h present in each term that's left over in the numerator. So we can factor that out as a GCF. H times 8x plus 4h minus 2 all over h. At this point, we can reduce the h's to 1 and then use direct substitution to plug in that 0 into h here. So we get 8x minus 2. So this is the derivative of f of x. Now that you know the power rule, hopefully you can see why it's so nice to have that power rule. Because really, if you know that power rule, you can find that derivative a lot faster. But there's 1a. 1b, it says use the power rule to find the derivative. Okay, well, using the power rule, I'm going to bring this exponent of 2 down and multiply by 4. So that's going to be 8x. And then you reduce the exponent by 1. 2 minus 1 is just 1. And then do the same thing for the next term. The next term is negative 2x, which has a slope of negative 2. And then the term 1 has a slope of 0. So we do get the exact same answer. All right, so here we're just going to run through some just very straightforward power rule problems. We got 4 times 8, which is, what would that be, 32x cubed plus 9x squared plus 2. Yeah, just wanted to double check, make sure I didn't miss any terms there. For b, we just have a linear function. So you should already know how to find the slope here without even using the power rule. The slope of any linear function is going to be the coefficient of x, so that's just 3. And for part c, h prime x is going to be, let's see, negative 24x to the 5th plus 24x, and then the derivative of 2 is just 0. So here's our derivative equation for h. Number 3 is the same kind of idea, except we're going to see a bunch of radicals and fractions in some of these expressions. And so what we want to do is first just rewrite them all as powers of x. So this first one, we've got x to the power of 5/3 plus 5x minus 2. I'm just going to actually rewrite all these, so that way we could just run through all the derivatives at once. So part B, I'm going to rewrite as x to the 1/2 plus 3x to the negative second power minus 1. And then part C, I'll rewrite as f of x equals 6 times x to the 7/3 plus x to the 3/7. Okay, so now we're going to go ahead and calculate the derivatives. So for part A, the derivative of f would be 5/3 x, and then 5/3 minus 1 will be 2/3 plus 5. For part B, f prime x, or the derivative of f, will be 1/2 times x to the power of negative 1/2 plus, or actually, since I'm multiplying by negative 2, it needs to be minus 6x to the negative 3rd. And then the derivative of negative 1 is 0. So we're going to leave it at that. For part C, 7/3 times 6, 7 times 6 is 42, so 42/3 times x to the, 7/3 minus 1 would be minus 3/3, that's going to be 4/3, plus 3/7 times x to the negative 4/7. Number 4 says use the power rule to find the equation of the line tangent to this graph. Okay, when we're finding an equation of a tangent line, we're going to get ready to use our point slope form y minus y1 equals m times x minus x1. And we need a point and we need a slope. So to find the slope, it's saying we want the point when x is 1, so we can substitute in negative 1 into the original equation. So let's see, 4 times negative 1 cubed minus 2 times negative 1 minus 6. That's going to be negative 4 plus 2 minus 6. Negative 10 plus 2 is going to be negative 8, unless I made a mistake there. For the slope, we need the slope equation. So we need to find the derivative. So h prime x, and I'm going to go and erase this scratch work here so that I can include the derivative. H prime is going to be 12x squared minus 2. So if I want the slope when x is negative 1, I'm going to substitute in negative 1 into x. Well, negative 1 squared is 1, times 12 is 12, and minus 2 is 10. So the slope here is 10. So now I've got my point, I've got my slope. Now I can just plug everything into my point slope form. Y plus 8 equals 10 times x plus 1. Number 5 is kind of a similar question. It says use the power rule to determine the values of x where this is a horizontal tangent line. So when we have a horizontal tangent line, that means that the slope is 0. So what I need to do is I'm going to set this equation. Oh, no. I'm not going to set this equation because I want the slope to be 0. So I actually need to find first what the derivative is. So 3 times a third is just 1. So x squared minus 2x minus 24 is going to be my slope function, or my derivative of g. Then I'm going to factor this because I want to know when is the slope 0. So if I set this equal to 0 and I factor it, I can find the two x values where that happens. So this will factor as x, what would this be? If we've got to multiply to negative 24, add up to negative 2, that's going to be negative 6. So x minus 6 and x plus 4. So this means the two x values that we have a horizontal tangent line at are going to be at 6 and negative 4. Number 6 says, use the power rule to determine the value of x for which the slope is equal to 13. So this is basically the same question that we had before, except the slope is 13 instead of 0. So we still want to find the derivative, and then we'll set the derivative equal to 13 and then solve. So f prime will be 3 times 2 is 6x minus 5. We'll set that equal to 13 because we want to know what x value has a slope of 13. I'm going to add 5 to both sides, so I get 18 equals 6x. And then finally, dividing both sides by 6 is going to give me 3. So that means that when x is 3, this quadratic has a slope of 13. Number 7, determine the derivative for each of these equations. And you can use the power rule, so these should be pretty easy. Now the first one is just a linear equation. You don't even need power rule for this one. All right, the slope's just 1. Okay, so dy over dx, the derivative of y with respect to x is 1. The derivative of y with respect to x for b, well, before I actually calculate that, and you could also write this, by the way, as like y prime. So either one of those is fine. For this one, I'm going to rewrite y as 4 times x to the negative first plus 4x plus 5. And then just use power rule here to find y prime, which is the same thing as dy dx. I get negative 4 x to the negative second plus 4. Part C, I'm going to rewrite this as 3 times x to the power of 2/3. So the derivative will be 2/3 times 3 is 2, and then 2/3 minus 1 is negative 1/3. The final one is a constant. If I were to graph this line, it'd be a horizontal line, and we should know what the slope of any horizontal line is, and it's 0. So that means the derivative here is just 0. The slope doesn't change, just like the slope doesn't change on a linear function. Okay, let's take a look at number 8. Given this function, determine the slope when x is 2. That's what this means. It means that the slope when x equals 2. So first, let's find f prime, or the slope function. Using the power rule, is going to be negative 6x squared plus 3. So the slope when x is 2 is going to be negative 6 times 2 squared plus 3. So let's see, what would that be? 4 times negative 6, it's going to be negative 24. Plus 3 is negative 21. Number 9, we want to find the slope when x is 8. So we're going to basically solve it the same way we did this previous problem. So g prime, well actually let's rewrite g first. So g is going to be 3 times x to the 5/3. G prime then would be 5/3 times 3 is 5. And then 5/3 minus 1 is going to be 5 minus 3 is 2/3. So it says you need to be able to do this without a calculator. And yeah, you really should be able to. All we're doing here is just subtracting 1 from 5/3. It's probably the hardest arithmetic that we see on this problem. Number 10, this could be our last question of the homework. Kind of a short homework here, but there's only so many different power rule questions I can ask you. And we will investigate some more on the next lesson. But hopefully at the end of this, you'll have a pretty good understanding and conceptual understanding of how the power rule works. So this says, for what values of x will this function be parallel to the line that passes through these 2 points? So 2 lines that are parallel, they have the same slope. Okay, so it's saying it has the same slope as a line that passes through these 2 points. So the slope of that line is going to be 13 minus 5 over 6 minus 8, change in y over change in x. And let's see, 13 minus 5 is going to be 8, 6 minus 8 is negative 2, so this is going to be negative 4 for my slope. So this is the slope, right? And we're going to use the slope to figure out the values of x. It's saying for what values of x will the tangent lines of this be parallel to some other line that has a slope of negative 4. So first, let's find our slope equation. That would be x squared, because 3 times a third is 1, plus 6x plus 1. We want to know when that's equal to negative 4, because that's our slope. So I'll add 4 to both sides, factor, and then solve each factor separately. So x plus 1 equals 0 and x plus 5 equals 0. That gives me my solutions as negative 1 and negative 5. And there you go. So yeah, after doing these 10 problems, you should be pretty well versed in the power rule. Like I said before, we are going to practice this a little bit more in the next lesson, and then we'll move on to some other derivatives that we can solve with techniques other than the power rule. Y'all have a great evening, and I'll see you next time.